Hello students. In my previous video, I had introduced you to the concept of 3D geometry and discussed the various concepts and results. So today we are going to take up the result for distance between 2 points. Between 2 points in space. Okay, so given any 2 points, so let the 2 points be P x1 y1 z1 and Q x2 y2 z2. Now we have to find the distance between these 2 points. Now whatever results we are going to take up in 3D geometry, they are simply extensions of the results taken up on a plane. As we have already seen earlier also that the position of a point in a plane can be found out by two coordinates x comma y. Same way, where x and y the coordinates of this point, which can be found out by dropping a perpendicular from the point on to the two axes, the x and the y axis, and the intercept on the x axis is the x coordinate, and the intercept by that perpendicular on the y axis is the y coordinate. And we had simply extended this to the 3D as if this is the x-axis, this is the y-axis, and this is the z-axis, and any point in space, it can be uniquely identified, or its position can be uniquely identified if we know three coordinates x, y, and z, where the coordinates of this point are found as an extension of this. Like we drop perpendiculars from this point onto the three axis. So let the points in which the perpendicular meets the three axes be A, B, and C respectively. So then the intercept along the x-axis is the x coordinate, along the y-axis is the y coordinate, and along the z-axis is z coordinate. Now going in this manner, each and every result whichever we do, they can be remembered or learnt as extensions of the corresponding results in the xy plane. So we know that given any 2 points, A having A on the xy plane having coordinates x1 y1 and B having coordinates x2 y2, the distance between AB is given as square root of the sum of squares of the difference between the x coordinate and the y coordinate. So x2 minus x1 whole square plus y2 minus y1 whole square. Now extending this to the 3D. So similarly, if 2 points P x1 y1 z1 and Q x2 y2 z2 are given in space, then the distance PQ between them can be found out by simply extending one more coordinate and one more term to this expression, that is x2 minus x1 whole squared plus y2 minus y1 whole squared plus z2 minus z1 whole square. So simply what we have done is we have added one more term to the same result and found out the distance between the 2 points. Now we will do the application of this formula into in solving various problems. So we'll be taking up the exercise 12.2. Now question number 1 is a simple straightforward, can be done very easily. In all the 4 parts we have to find the we are given a pair of points and we have to find distance between them. So let's for example take up the first part, and in this the 2 points are having coordinates 2 3 5 and 4 3 and 1. So let us call them A and B. So the distance AB will be equal to the sum of squares of the difference between the each of the coordinates. So x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So we get AB is equal to square root of 2 squared plus 0 square plus minus 4 square, which gives us square root of 4 plus 0 plus 16, which is square root of 20, and we simply get the answer as 2 root 5. So in the same manner we can do the remaining parts of this question. Now let's see question number 2. We have to check that the 3 given points are collinear. So let us name them as minus 2 3 5. B is 1 2 3 and C is 7 0 minus 1. Now we know that given any 3 points, let's call them PQR. Any 3 points are said to be collinear. So P, Q and R are collinear if the distance between PQ, the sum of the two distances between PQ and QR is equal to the distance between P and R, that is PR is equal to PQ plus QR. So now same way here, if we have to show that these 3 are collinear, so sum of any 2 distances should be equal to the third distance. So let's find the distance between AB, BC and CA, and then we'll see if sum of any 2 distances is equal to the third, we can easily conclude that they are collinear. So let's see, AB will be square root of, now suppose this is x1 y1 z1, x2 y2 z2 and x3 y3 z3. So x2 minus x1 is 1 plus 2 whole square plus y2 minus y1 plus z2 minus z1 whole square, which comes out to be square root of, now this is what, 3 square, which is 9, plus minus 1 square is 1, plus minus 2 square is 4, and AB comes out to be square root of 14. Now same way we find BC. BC will be square root of x3 minus x2, that is 7 minus 1 whole square plus y3 minus y2 plus z3 minus z2, which gives us square root of 6 square, which is 36, plus 2 minus 2 square, which is 4, plus minus 4 square, which is 16. So BC gives us, this is 40, so 56. 56 is, so this is the so if we find 14 into 4, that is 56, so we get 2 root 14. Now the last result is if I find AC. Now AC will be square root of, now x3 minus x1, that is minus of minus 2, which is plus 2 whole square, plus y3 minus y2 whole square plus z3 minus z1 whole square, and when you solve it we get it is equal to square root of 9 whole square is 81 plus minus 3 whole square is 9 plus 6 whole square is 36, which comes out to be 90, so 126 square root. So let's check, it will be equal to 9 into 14, 14 into 9 is 36, so 126. So this gives you 3 root 14. So clearly AC is equal to AB plus BC, it implies that A, B and C are collinear. Now, in order to prove, now question number 3. Now, question number 3 says, verify the following. Now, first part says that the 3 points 0, 7, minus 10 and 1, 6, minus 6, and the last one is 4, 9, minus 6 are vertices of an isosceles triangle. So, are vertices of an isosceles triangle. Okay, now in this case we know that a triangle is isosceles if AB equal to AC and AB plus AC is greater than BC. It is not equal to BC, but it is greater than BC. So we will check for all 3 points. Let's call that P, Q and R. We'll check for PQ, we'll find QR and we will find PR. Okay, and then we'll see if the sum of if any two are equal and the sum of those two is greater than that of the third one, we say that these are vertices of an isosceles triangle. Now the same way we do question number 3, second part. In the second part we have the 3 vertices. P is 0, 7, 10, Q is minus 1, 6, 6 and R is minus 4, 9, 6. They have to be shown to be vertices of a right angled triangle. Now what is so special about a right angled triangle? Again the same thing. Now suppose we call it A, B, C are the vertices of a right angled triangle which is right angled at B. Then we should have AB whole squared plus BC whole squared should be equal to AC whole squared. So if we will find PQ, QR and PR, and if we can prove that the sum of squares of any two is equal to the square of the third one, we'll say that these are vertices of a right angled triangle, right angled at the common point B. So if the sum of any two vertices is squares of any two vertices like sides is equal to the third one, so in those two sides whichever is the common vertex, that will be the point where there will be a right angled triangle. Now same way for the third one, we have to show there are 4 vertices of a parallelogram. So we are required to show any 4 vertices are given and we are required to show them to be vertices of a parallelogram. So let's just call them A, B, C, D. Now when are these vertices of a parallelogram? You can show that the opposite sides AD should be equal to BC and AB is equal to DC. The length of the opposite sides, that is this is equal to this and this is equal to this. So this is a way of showing parallelogram, that they are vertices of a parallelogram. Okay, now the fourth question is question number 4. If we see, it is the equation of the set of, find the equation of the set of points which are equidistant from 2 points. Okay, so let the 2 points be 1, 2, 3 and B be equal to 3, 2, minus 1. So let the required point be X, Y, Z. Okay, so we are required to find the set of all the points which satisfy the condition that, let us call it as P. Okay, so to find the condition, to find the set of points P such that AP equal to BP. Okay, so we have taken an arbitrary point. We have taken an arbitrary point P, X, Y, Z, and we have to find the path followed by this, or the locus of this point, or we have to find the set of all the points which satisfy this condition. All three things are three different ways of asking the same thing. That is, you could have been asked to find the locus of P, which is the same as the path followed by P, which is the same thing as the set of all points P such that AP equal to BP. So what we do is, so we are given 2 points, we simply take them as the 2 points are A is 1, 2, 3, B is 3, 2, -1, and P we have taken as X, Y, and Z. So what we do here is we find it as, so given that AP equal to BP, so simply by using distance formula, so therefore using distance formula, we get square root of, now AP would be x minus 1 whole square plus y minus 2 whole square plus z minus 3 whole square is equal to square root of x minus 3 whole square plus y minus 2 whole square plus z plus 1 whole square. So squaring both sides, we get x minus 1 whole square plus y minus 2 whole square plus z minus 3 whole square equal to x minus 3 whole square y minus 2 whole square plus z plus 1 whole square. Now just open the squares, cancel out the square terms, means x square will cancel out in both sides, similarly y square will get cancelled out, and similarly z square can be cancelled out. So we get simplifying both sides, we get an expression in x, y, z and a constant, which gives us the set of points which gives us the equation of set of points which are equidistant from the two given points. Similarly, question number 5 can be dealt with. It is also to be dealt with in the similar fashion. What is given to us? We have to find the equation of set of points, the sum of whose distances from A and B is equal to 10. So, given 2 points, A is 4, 0, 0 and B is minus 4, 0, 0. Let P be X, Y, Z be a point such that AP plus sum of squares of their distances is equal to sum of whose distances from A and B is equal to 10. So AP plus BP equal to 10. So what we do is we simply find AP plus BP would be equal to what? X minus 4 whole square plus y square plus z square whole under root plus x plus 4 whole square plus y square plus z square whole under root is equal to 10. In order to remove the square root, we don't square at this stage, we take this term to the other side. So this can be solved as square root of x, x plus 4 whole square plus y square plus z square equal to 10 minus square root of x minus 4 whole square plus y square plus z square. Now squaring both sides, we get, here we get x plus 4 whole square plus y square plus z square equal to 100 plus x minus 4 whole square plus y square plus z square minus 20 square root of x minus 4 whole square plus y square plus z square. Y square, z square get cancelled on either side, and then we open these brackets, we get x squared plus 8x plus 16 is equal to 100 plus x squared minus 8x plus 16 minus 20 square root of x minus 4 whole squared plus y squared plus z squared. Here x square also gets cancelled, and what we get is, taking only the square root term on one side, we get 20 square root of x square plus y square plus z squared minus 8x plus 16 is equal to, taking the remaining on the other side, we get this 16 also gets cancelled, so we have taken this 20 to this side, this term to this side, and 8x is taken this side, so we get 100 minus 16x. So all the terms have been taken up now. Now divide throughout by 20. So what we get is, this can be taken as, you can take square root of x squared plus y squared plus z squared minus 8x plus 16 is equal to, this will be 1 upon 5 minus 4, this will go 4 upon 5 into x. Now again squaring both sides, we get x squared plus y squared plus z squared minus 8x plus 16 is equal to 1 over 25 minus 2 into 1 over 5 into 4 over 5x plus 16 over 25 x squared. Now collecting all like terms together and simplifying, we get the required answer. So what we get is, x squared term, it becomes what, 9 over 25 x squared plus y squared plus z squared. Now this 8x minus 8x, and this one is minus 8 upon 25, it goes here, it becomes minus 8 plus minus 8 can be taken common, you get 1 plus 1 over 25x, and plus 16 minus 1 over 25 equal to 0, which can be further simplified, and that gives us the, which can be simplified, okay. So with this, you can do, this exercise is over, and you can do similar questions of this kind. Okay, thank you.